I guess we are on air right now. So,
Starting this
Randia,
three.
you
All
can
right.
start.
Thank you, Adil. First of all, hello everyone. Good morning. Good morning. Good afternoon. Whichever time zone you are in. Also, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Back
wabarakatuh.
again with us. First of all, me, Rendia, and as a host, and we have our guest here, Andra, and our friend here, Adil too. So
Alright, guys.
this Sunday podcast topic will be centered around what is it, Andra? You what are you going to talk about today?
Okay, guys, right now we're gonna talk about processing units in chemical engineering plants called distillations, as well as gas absorptions,
Distillation and gas
distillations and gas
absorption.
absorption. Yes,
Very fascinating. Go on, then explain it to us, and why
all
is it
right,
so
all
interesting to
right.
talk about?
Let me to share my own screens to uh, explain it.
All right, Picasso.
Right. All right. Have you guys seen it?
Yes, I could.
Yeah, I can see the presentation right now.
Right. Assalamualaikum, guys. I hope that you
Waalaikumsalam.
are always in great way and means
Testing, testing, testing.
healthy conditions. And today, I want to give some of my knowledge about distillations and gas absorptions as a chemical engineering unit. Okay, next to the agenda today.
Mhm.
Uh, okay, we're gonna talk about the first introductions and next definition of both units. After that, there is a pilot scale or AK lab scale in the first stage, and how it would like when it comes to industrial scales, and finally, we're gonna get close. Okay,
All right.
jump to the next slide. All right, introductions. Okay, um, okay, guys. If you still do not know about chemical engineering is a branch of engineering that focuses on the chemical processes. Okay, and chemical processes needs plants that consists of several units operations. Okay,
All
and
right.
one of them is the way how to separate between two or more molecules. Okay,
All
and
right.
two
Mhm.
of them are distillations and absorptions. Okay,
Got it.
all right.
So this is the process, right? What are the process in chemical engineering?
Yes, one of the process of chemical engineering that
Like this.
I'm still
Mhm.
learning also.
All right. So this is basically like a step by step. Like this is the step itself is called distillation, and other step is called absorption, something like that, right? No.
Yeah,
Oh, sorry. Maybe I was wrong.
yeah. These two are different, but in the same method.
This
There's
is the same method.
separations.
It's separation step,
Yeah,
like
and
method.
as you
Okay.
can see in my slide that I already made,
Mhm.
the separation method that could be divided by two kinds, and there are distillations and absorptions.
Got it. Okay.
Right. The first distillations. Uh, it is intended, uh, Rania, to separate between vapor and liquid phase based on boiling point. Okay. Uh, and the use of distillation is already widespread. I mean, we already learned it when we were in school, right?
Yeah,
So
like
maybe.
for perfume. I still remember high school. Like we use it for perfume and uh, I don't know. The only example that I could think of is actual perfume, like
Oh,
to make gas.
yeah, yeah, yeah.
There are
Maybe
any
it's true. And uh, let's say it looks like I have the mixture,
mm-hmm.
of ethanol, right?
Yeah.
And let's say the water the water has the boiling point of 100 degree Celsius.
Right.
And then the second component of this mixture is ethanol that has let's say 70 degrees Celsius. Okay.
Okay. All right.
Our mission is to separate between two components in this mixture, right?
Hmm.
So we need to to heat this mixture. I mean, let's say the temperature of the heating is 71, about that, 71 degrees Celsius. And then what happens? What happens is that the ethanol will be vaporized to the up of the column, left the water, and yeah, it's separated. As simple as like that.
So
So the
you
the ethanol will be removed from the mixture, and it just left the water alone in the below.
so you use like the gap of boiling point of each element to ensure like to able to separate those, right? That's the point of distillation,
Yeah,
to use
we
the gap
we
of boiling point.
you are very true, man. We actually utilize the gap of the boiling point,
So
and the lower the boiling point,
mhm.
the easier it would be removed.
I see. So for example, like this example, like ethanol and water, like for example like oil and water, you can call it can you call it distillation if you have like oil and water and you want to separate them by boiling the water itself?
Yeah. It can be boiled too. Yes.
Wait,
All right.
seriously?
Yeah.
Seriously?
But when you talk about it, I mean the polarity of both
Oh yeah.
oil and water is, I mean, it's already separated. Then
Oh yeah, so
it
you
would
don't
be
have
it
to,
would be
right, right.
easier to separate
Yeah, yeah,
in
yeah,
other ways,
yeah, yeah, so you
in
don't have
physical
to
maybe.
use distillation per se, right? Okay, I get it.
I mean,
But
it looks like the separation method of distillation is utilized when the mixture is one polar.
like a solution.
Yeah, solution of water and ethanol. I mean, it's polar and polar, ammonia water polar and polar, and crude oil non-polar with non-polar.
Oh, I see.
Yes, crude
One
oil.
question.
Yes.
Another question: do distillation consist of only boiling, or also the condensation part? Like after you boiling the water, you condense, right? The water
Yeah,
to
we
other.
condense we
Yeah,
condense
will
it,
be condensed.
and
Is it part of distillation?
you are true. It's part of distillation, and we are
I
gonna
see.
talk this in the later slides.
Okay, all right, good.
Yeah, and the next we have absorptions. Okay,
Okay, okay.
actually, absorption only happens in gas. So let's say
Yes.
you have different. I mean, like I said, this is a gas, and you have gas, and it consists of two components. Let's say A and B, right? All right. So let's say you want to separate between two of them, and the additional information is that one of them is inert. Let's say I choose A as an inert gas, inert particle, meaning that it's not really reactive.
Hmm.
It's not really a reactive components inside the gas. And then what I'm supposed to do is that I need to flow the gas through the liquid to be B could be transferred to another liquid.
Okay. To another liquid.
All right. So When I do this, the B in the gas will be omitted, and the solution will be transferred. The particle of B will be transferred in liquid. So I flow the gas through the liquid, just in nutshell. And the example of these operations can happen in the urea fertilizer productions, formalin productions, sugar bleaching, as well as water purifications. Nah, and this is what I wanna discuss later about carbon capture. So you can capture the carbon with these absorptions.
Okay, can I ask you a question? Sorry if I
Oh,
ask
okay,
question.
yeah. You can do it.
So, you say that this gas absorption separation method is to separate two component of gas, right? Like A and B.
Mm-hmm,
Is
mm-hmm.
A and B could be a compound or just an element?
Oh, yeah. You are true. It's such a molecule or compounds. In other words.
Yeah. So it could be a compound rather than just element. Like, you say A is to be inert, right?
Yeah,
Uh,
it has to be inert because when it's not inert, it could react with liquids too.
hmm. So A is inert. Usually, if something is inert, I usually think of a noble gas like an element, right? Can a compound be inert?
Uh,
Oh, Andrea asking
yeah,
is very
maybe
hard.
Sorry,
the
maybe yeah. Sorry, I might be wrong.
maybe when the it's actually it varies. It varies. The compounds
Oh, it
that
varies,
yeah
but
can
yeah,
consist
okay.
of the inert and non-inert.
All right.
Yeah, it
Okay.
depends on the data that you have.
I see. I see.
Yeah,
So,
and yeah, we're gonna, let's say, carbon capture for
huh?
first, right?
Yeah.
Carbon capture. Let's say you have the CO2
CO2, CO2, man.
CO2.
yeah, carbon dioxide emissions
Hmm?
gas, right?
Yes. Right.
Flow through after the productions of your product,
Hmm?
and the CO2 or carbon dioxide is not only carbon dioxide. I mean, it's inside in the gas, right?
Yes, that's true.
The gas could consist of what?
Nitrogen,
Air,
oxygen.
or udara. Yes, it could be oxygen, nitrogens, etc., as
Yeah.
well as carbon dioxide. All right.
All right.
When you want to separate between air and carbon dioxide, okay,
Hmm?
you need to flow the gas which is absorbent. I mean, the liquid that can absorb the carbon dioxide, or the B component is called as absorbent.
Oh, I see.
Absorbent. All right,
All right.
and this
Okay.
gas, I think it's amines. In Indonesia, we could say amina. We threw the gas through the gas. We threw the amine through the gas, and the carbon dioxide will be transferred to the amine.
Hmm.
So the 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 level of carbon dioxide in the existing gas is very low after this gas is flowed through the absorbent liquid.
Ah.
We will learn it later.
Okay. All right.
Okay.
As a liquid, so it's bonding B to the liquid. What it means is to. I mean, I get it about separation, but I guess is it true like this separation absorption method is for extracting inert gas, or it could be both A and B?
Yeah, maybe it's kind of extracting
A
inner.
gas. inert gas,
Ma-
A
you know,
gas.
do you mean that extraction like you pick the gas to the liquid or what?
Oh yeah, for example, like
Or
distillation, you could choose between ethanol and water, right? Like the water is from the first container, and the ethanol is from the condensation of the ethanol from boiling the ethanol itself. But in absorption, uh, the liquid, the B part, the B gas, yeah,
yes,
is in the liquid, right?
yes, the
Some
B from the
other,
gas is transferred to the liquid.
yeah,
Yes.
liquid absorption, absorbent, what is, oh, amine, to be
Yeah, for
but
example, like
yeah,
I mean that's why we call the process is absorption, because the liquid that which is absorbance will absorb a
the
component from the gas, let's say B, to the absorbance, and left a component behind the gas alone.
yeah, leaving
Yes.
the A component. Yeah, okay, I get it. All right. Hmm.
And
I
next,
think I understand. Moving on. Okay,
all right.
distillation.
No worry, because I will explain it more
All right,
later.
thank you, thank you.
Distillation first, we
Moving.
can talk about it. Okay. Distillations. In distillation unit, the mixer solution is heated. Okay,
All right.
like what I already depict below. You can see uh, that most liquids, I mean, which it must have, you know, the higher boiling points than the vapor.
Hmm. True.
All right. Um,
I get it. Hmm.
so the V or vapor will be separated from the liquids, and then in the first it would be like this. In the first, it's X and Y in the first, but when it's already boil it until reach the lower. All right, the lower is Y.
Hmm.
I mean, we can say that the the boiling point of X is higher than Y. So Y would jump to the vapor first, and the the solution will be pure X.
I see.
Ah, maybe you can see the progress here, Rendia. All right. As you can see in the lab scale or pilot project, because yeah, I already knew about it, and as I already said to you, Rendia, you can see that the water boiling point is higher than.
Salt
Sorry. The water, the
is
water has the boiling point which is lighter than
lower
sodium
than
hydroxide.
salt. Yes.
Lower, yes, lower. It's not uh one 1.388, but it's 1,000 actually.
Oh, 1,000.
1,000.
Yeah,
It's so
it's
low,
much
man.
higher.
It is a
Yeah, it's
very
1,000
fatal typo,
because
actually.
uh the picture, I mean, describes that the water will be distilled here from here.
Oh yeah, that's right. Oh, I see. I see.
Do you get the process?
So,
Right?
because of this, I mean, in the beach, when uh, a salt farmer wants to make a salt, they actually um, boil the seawater, right? By, um, what is it? By,
Distillation.
yeah, by the sun shine.
Radiation.
Sun
Yeah,
ray,
Yes.
sun
Yes.
heat.
yeah, by the sun ray, and then um, the water will be evaporated, and it only left the salt in the.
Left the salts on the ground.
It's actually distillation process.
Correct.
Yeah, you are true, Adil. This
I
is how the
see.
distillation works.
Oh, I get it. Thank you.
Yeah. However, bear in mind, guys, that when you do lab scale, it doesn't really represent the actual one.
Oh.
Maybe when this is, you know, it it doesn't include the relative humidity, but why the salt that farmers do in the sea could the water could boil up, although the temperature of the sunlight is not 100 degrees Celsius.
Oh yeah,
Because
that's actually our I
Yeah.
used to have that question and I still have no idea how to the answer as ideally.
Yeah, that is interest. That does interest me. Like, it could not be like the environment there could not be in 100 degree, but how could it be boiled?
Yeah, I mean, how could water be boiled? Because water has 100 degrees Celsius, right? But it it is gone when we put it in the street. Like
same as when you dry your clothes
yeah,
outside.
that's also true. Like, how could that happen if sunrise is like 45 degrees Celsius or lower?
Yeah, as long as I know, the humidity plays the role too. The
Like,
water, I mean, not the water, the air or udara, flows through the object that you want to dry, and yeah, it happens.
so basically, a dry air will take water, like making it more humid, the air, but in the, well,
Yes, you are true, maybe.
yeah, like in small scale, the air will be more humid after you got the water from the clothes, something like that.
Yeah, you are true, Ren. You are true.
So it's like, uh, so is it like in the sea region the humidity is high because much water is like getting sucked to the air, something like that?
Getting up to the air, yes. Yes, Rendia, you are true. That's why in
Yeah, that's
Indonesia, which has the longest coast, yes, the the longest coast length in the world, has higher RH or relative humidity rather than Arab Saudi or uh, America.
So you mean that stuff would be longer to dry it up in Arab Saudi rather than in Indonesia because Indonesia has higher humidity?
I mean, like we have more relative humidity because it absorbs a lot of the seawater.
Okay,
Hmm.
okay.
I
This
guess
My point
seawater
is like that.
context. I see. Okay.
I guess this is one of the factor, since we are live in coastal island nation rather than a very big nation like, let's say, Brazil, even though, or Cuba, even though they are in equator, something like that. But what I get what you mean. Like, this is one of the maybe one of the factor why we Indonesians have a relatively high humidity. All right, so this is distillation, to distill water from salt, to
Okay,
distill
Ren. Yeah,
salt.
this is what you mean as a condenser.
Yeah,
You got it.
I guess.
You are true. Yes, and the water, which is just vaporized by the solution or mixture between salt and water, would be condensed in this part in order
Hmm.
to to make it separate and store it into the
The
batch.
container.
Yes, the this glass.
Um, is it possible to use it as for purifying water? Like, let's say example, like, drink water, like from tap water to drinking water, like, at least from lakes or from any kind of source of water, you can distill them to extract water from any other dangerous chemical. Is
Yeah,
it used for that too?
it reminds me when there is reports or research, shows you can extract water from your urine.
Oh,
Wait,
yeah, yeah,
what?
yeah. I
Really?
remember. Yeah, that's true.
Oh,
I saw that.
it is actually from the underwater world I saw before in a movie. where the main character P, and then there is this tool that extract water out of the P.
Distill water from P. Yes.
But
Yeah.
does it use distillation?
Yes.
Oh, I see.
Oh, really? So you have to heat it up?
Yes.
Oh, its smell
However,
must be
when
bad.
we use this, remember that the where's my orange? Okay. When you wanted to heat it up, you need to mine the burner, right?
Mm.
It will take energy, and not to mention the condenser, the energy again. Then I mean, you need to consider about the amount of energy spent in this work.
The tools, so yeah, all right. The tools
Yes.
also. Well, I don't.
Maybe let's say it would be much costly to distill water from P than distilling water from your tap water.
I
Because
mean,
in urine water,
Mhm.
your urine would be so many minerals inside that hinder the water to evaporate. So you need to more and
Consider
more
that.
energy, yes, to heat it up.
Well, I guess that's true, and the smell too will be bad, right? I mean,
Smell
ammonia
really
is
bad.
right. I
All right.
mean, the let me just add this one. Like, this is the lab tools, right? But I kind of think about the makeshift. If I were in the jungle or
All right.
something like that,
Let's
I
go
would
to the
like
jam
to.
because we have limited time.
Okay, okay, go
All right.
ahead.
This is the
So this is the
industrial
industrial.
scale.
All right, all right.
All right. So as you can see, that's it's such a the penyulingan minyak or crude oil distillations.
This is a crude oil. Okay,
Yeah, crude oil from the tank flows to the heat exchanger functioning to heat it up,
okay.
and in this filter, the crude oil will be separated between the salt and the crude oil in order to purify it more.
Hold on. The input was oil and water.
The input is the crude oil. Crude oil could contain some minerals
I
called
see. Okay.
salt.
Right. Okay.
All right. After that, it jumps to the heat exchanger to be heated up again, and then from furnace, yeah, of course, it would be that hot 370 degrees Celsius, right?
Mhm.
As you can see, it's called as the tri column, the tri distillations column. The tri distillation column, which has tri or sekat-sekat insides to
Okay.
separate between the residue, asphalt, heavy gas oil, light gas oil, resins, heavy naphtha, light naphtha, as well as the fuel gas that you want to separate. Okay.
Oh, so this is like one machine to extract all of the chemical.
Yeah, you
Oh,
can
I
extract
see.
Pertamax, premium,
Yeah. Wow. That's.
analyze here
Oh,
I
based
so
thought you
on
were
the
using
boiling
separate
point,
machine.
also
as well as the asphalt, which is the heaviest part of the crude oil.
Hmm.
oh, wait, asphalt. Oh, so from crude oil, you could make like five, more than five components out of it.
More of like five
Yeah,
types of.
from crude oil alone, you can produce various chemicals. Sorry, not heat exchanger. You can from the crude oil you can create a lot of products
By using distillation.
by using distillations.
Oh,
Yes,
I
Mm.
like
see.
bitumen, AK asphalt, uh, naphtha or kerosene, which are used for uh, airplanes fuels, as well as gasolines, which consists of Pertamax, etc. in just one unit called the distillation column, which has the color of blue.
I see. I see.
Yeah, like this. Right. Next, part of distillation unit. The first there is a reboiler, which is to heat a mixture in liquid, and yeah, of course, the main part distillation column. Uh, it could divided it could be divided into the try or packing style sections, and then condenser to condense the vapor from the column to be liquid, and then
Pepper.
lastly separator to separate the distillation results.
I
Right
see.
next to jump gas absorption.
Okay.
Yes, as you can see, in gas absorption units, a mixture of gas passes a columns and meets absorbent liquids. In that way, the solid in gas could be transferred to the liquid phase, as
Mm.
I already said in the first slides. At the same time, that maybe the molecules dissolve in the liquids tend to return to the gas phase. So it's kind of exchange the molecules from the gas phase and the liquid phase. As you can see, the pictures below represents the how the absorption works.
I see.
Wait. So,
Hmm?
but about humidity that air could absorb heat. Is it absorption or
Yes,
not?
yes, we can say that
So
absorptions.
you mean water dried up in a cloth is combination of absorption and distillation, or not? Or it is just absorption, or whatever, or what? I don't know the
I don't
answer.
think so. I think what it meant, like absorption meant, like you have a gas, right?
Yeah.
You pass through a column
Oh
which
yeah,
have
that's
some
right.
kind of liquid,
So
which we're going to absorb some of the gas there, leaving the
yeah, that's
inert
right.
gas,
So
and
the
then mm,
the water, the liquid doesn't dry it up or
yeah, doesn't
anything.
dry it
Oh yeah,
up.
that's right.
Just
That's
they
right.
just absorb the gas that
Yeah, I get it.
bonds with it,
That's right.
and then when of course the gas that have been liquid could be returned to the gas after a certain
Yeah,
while.
of course,
Mm,
I get it. Thank you,
I
Ren.
see.
Thank you, Thuran. Yeah.
But
All
it
right.
is pretty cool, I
The
guess.
gas absorption will work like this, guys. So in this example, x x repression
Represent.
liquid,
Represents.
x represent liquids, and y represents the gas, right?
Yeah, right.
All right. Uh, which one would we divide from those two phases? Exactly, it's gas. The gas contains
Yeah.
two components, as I already said. Uh, so the X or liquids,
Oh.
uh, goes down like this.
The gas goes,
As
the
the
liquid goes down,
Yes,
the
as
air goes
the
up.
the gas from the below goes to the up.
Ah,
Yeah, like this. The liquids turn down and the gas turns up. So when the liquid downs, the gas turns up, and yeah, it meets together, right? So
mm,
the component from the gas will be transferred to the liquids below,
mm.
and yeah, as the number four liquid exit.
Oh, fascinating. So they kind of the water like they trickle down to the bottom kind of like rain to maximize the surface area that could be bound to the gas, right?
Yeah, exactly, man. As you can
That's
see,
that's cool. That's pretty. Hmm. I will
from
research
the lab
more.
scale. The lab scale.
So
In this
good. All right.
example, I choose the carbon capture because,
Mm.
as you can see, that the global global people are concerned about the you know uh, the pollution's problems.
Oh, so
So we have the amine liquid. We have amine.
RX and H2. R. What is R? Radion. Radon.
Yeah. So in this amine will
Hmm?
absorb the flue gas, which is CO2.
CO2.
Yes, and it will the CO2 will be captured or trapped in the amines, and which which uh, which turns to be like this, the green color. As you can see, that's the below contains the higher level of CO2, and the upper contains the lean phase. I mean the lighter CO2, and it could be recycled to the first phase to capture more and more CO2. And then after that, we have the saturated or the larutan jenuh of CO2 and amine.
Mm.
Yeah, and yeah, it's up to you whether you wanna recycle your CO2 to the another place, or you wanna store the CO2 below the ground in order to prevent the carbon emissions to the world.
I see. Kind of like dry ice, something like that.
Like dry ice.
Yeah, like making dry ice, cycle it. Yeah, okay,
Uh,
alright.
I forgot about it. To be honest,
Well, dry ice is just
how does it work?
CO2. Dry ice is just a CO2 that has been cold, like freeze it. Like it's just for well, any kind of
Okay.
freeze agent or something like that.
Does that apply? At, is it require another chemical, or just the temperature matter?
No, it's only like CO2 just cooled down into the
Oh,
solid phase.
solid phase.
Yeah, right.
Oh, okay, okay. So, yeah, so in dry ice, we just have to make it cool in order
Yeah,
to
just
be
cool it down.
the solid.
Hmm.
Okay, that
Okay, moving on.
moving on. All right. So in this
Industry
industrial
scale.
scales, I or I also choose the carbon capture, and it works like this. In the first phase or stage, you have flue gas, which is contains a lot of carbon dioxide from below, and the absorbent from the up.
Mhm.
So when the flue gas meets the absorber, the carbon dioxide from the flue gas will be transformed to the liquid, which is amine, and it
Mhm.
goes to this, while the vapor contains almost no carbon dioxide, so it's clean.
Ah, I
You
see.
can waste to the air, as it's already pure from the carbon dioxide.
Wait, guys. I have no idea about. So this is about separating CO2, right? In in the air, right?
Yeah.
And
Yeah,
then
Eh,
true.
hmm.
You are true, Adil. Yes.
okay. So what is flue gas? So it starts with flue gas, right?
Okay, flue gas. In other words, you can say that it's such a waste gas,
Or waste
Hmm.
gas. Okay.
waste
So,
gas.
but it starts with flue gas.
Yeah, like a mixture of waste gas to be exact,
Yeah,
right?
it's kind.
Okay. So it starts
Imagine
with
like
flue
you
gas,
have
alright.
you have a car. Okay, you have a car, and you need gas lines, and gas lines is could produce power, right, to
Yeah,
to
that's
to
right.
move your car, and it would produce also the emissions, which is flue gas
All right.
from
So
your
yeah, I guess I get it. I
outletting
get it.
hole.
And then it went through. It goes through an absorber here, and the vapor here would have CO2. Would
Sorry.
have, so the flue gas here goes
Mm-hmm.
to an absorber, and then
Yes.
it produces vapor which doesn't have any CO2.
Yes, you are true.
Oh,
You are
okay,
true,
I
Adil.
get it.
No.
Maybe it still contains carbon dioxide, but in the small quantity.
Yeah,
Let's say
at
just
least.
5 until 10% of
Yeah,
CO2.
okay, okay.
Yes. Nah, that's our homework or PR. We, as a chemical scientists, we
Scientist.
need to upgrade the process, how to get the smallest quantity of carbon dioxide from the vapor.
Hmm.
Yeah, and then after that, you can desorber your carbon dioxide to the another place like underground or something. I Yeah, something like that.
All right.
And then
Is
yes,
Okay,
it's
okay,
already
go on,
finished.
go on, go on, go on, go on.
gone.
Knowledge is that which benefits, not that which is memorized.
All
I
right.
think
That's
that's a good quote.
yeah, quote of the day.
What does it
Siap, siap.
mean?
Yeah,
But good.
maybe
There's
memorizing is important, but don't forget to make it real,
Yeah.
make it beneficial for others.
I see.
Uh,
All right.
oh, so you're
Okay.
done.
Good enough. But
Okay,
I
so
got a
okay,
question.
so
All right.
Randy up first, Randy up first.
The absorber, like the water, not the water, like the chemical, the liquid chemical for absorber. Uh, is it recyclable,
Oh, good question
or
there.
I
The
mean, it
liquid
is
of what?
recyclable. The absorber water, the liquid of
Oh,
the
okay, yeah,
absorber.
it's called absorbent. And as far
Yeah,
as I know,
absorber.
let's say amin, right? Amin.
Yeah, I mean, like I
Yes,
mean,
it's recycled.
uh,
It can be recycled
does
because
it?
when you
Uh,
absorb the let's say carbon dioxide,
yeah.
right? The carbon dioxide could be released in somewhere, and the liquid that could absorb could be used again.
Oh, is it fully recyclable? Like fully 100% fully recycle, or just part of it, like 50-80% of it?
Yeah, maybe about 98. Yeah,
Oh,
90%
about
could be
90.
recycled. Yes.
So they are
Maybe some
waste
of them
absorber.
will still be stuck with the carbon dioxide.
Ah, I
Uh,
see, I see. That's
yeah,
good
that's
enough.
what I
All
know
right.
from the experience.
All
Good.
right.
Yeah.
So, okay, I have a question. I don't really get it when we talk about condensation. So, condensation is, there is this liquid. No, no, no. There is this gas state, right? And then we want to change it to a liquid state. And in order to do it, we have to condense it, right? Is it condensation mean?
Yeah, it's true. This is how the condensations mean.
Okay, can we go to the site where we want to separate salt and water?
Of course. Let me try to share you anymore. It goes like
Okay.
this.
All right.
Uh,
Oh, I get it.
right.
Oh, I
You can see,
see.
right?
Okay,
The
so
condensation means to to retrieve the amount of water to be a liquid from the gas phase to the liquid.
I see, I see. So
Yes, to be
so
turned down to be here. Maybe when the condenser is absent from the distillation units, it will be stuck uh, on this glass
oh, I see, I see, I
in
get it.
Erlenmeyer. Or I forgot about the glass.
Uh,
Hmm.
Yeah,
so
yeah,
in crude oil distillation, there is also a condensation process, right?
yes. As you can see from here, um, there is condense.
Oh yeah, that one is condensed. So about kerosene, light gas oil, um, it does it also use condenser?
Mm,
Do they use
this is
condenser?
there are some the tools. It could be meant as the heat exchanger.
Oh, okay. For the residue, it is the asphalt.
Yes.
Wait,
I'm not sure
what?
about it. I'm not sure if it will be cooled down until the standard temperature, which is 25 degrees Celsius. Because once you cool down the asphalt or kerosene, not kerosene, bitumen, you will find that the bitumen will be solid, right? I mean, it's gonna be hard to transport. I mean, maybe it would be cooled down, but not really until the 25 degrees Celsius, but maybe until 300 or something. Yes, but uh, for for gasolines or naphtha, it would be cooled down until the 25 degrees Celsius standard temperature, maybe. Maybe
Okay.
that's what I know. Yes.
Okay. So tankage is the starting place. It's just a starting
Yeah,
place.
it's STP or storage tank.
All right. All right. So, um, have you ever seen one before about this process in real life?
This process in real life, actually, I've never seen it.
Oh,
I
you
never,
never saw
but
any.
but I did for the spare parts like heat exchangers or valve like this.
All right. All right.
I
So,
already saw it, as
okay.
well as
Okay.
the pipe.
But YouTube, at least you have seen one, right? With in YouTube. No, no, not two.
Yeah.
Oh,
And when you wanna learn about the unit operations, yeah, now YouTube has provided a lot of courses that could be used to uh, acknowledge how to work
all right. All right. So, do you know about cements?
cement
Yes. Is it cements
for
from
building
oil?
or what?
Yeah, cements for building.
Oh yeah, because it's still vague.
Yeah, cements for building, of course.
What kind of order cement do you think?
Yeah, of course
Okay, all
from
right.
building. Is it
Cement
from
for
crude
building.
oil?
I think.
Cement it. Okay.
I think.
Maybe it uses some distillations too, but
You know,
I don't think it is crude
because
oil though.
you know what, every single productions, let's say, like you want to purify the gold, right? You want to purify the gold or cement, maybe from this from the start, uh the objects that you want to separate, are still in the mixture of other pengotor, what the pengotor actually
Residue.
residue.
okay,
Yeah,
okay.
residue. Maybe it's still in the mixture of residue, so you need to purify it until the certain percentage of yield.
No,
Yeah.
no, no. Just wondering about cements, because I saw a Veritasium video about concrete, and it talks about cements, and in cements in Indonesia, like cement tiga roda. I saw one before when I went to Banten. It is, I think, around. Yeah, it is. I don't
Merak.
know. No, I forgot about the specific place, but I think it is around Banten. And I saw a very large chemical plants in there. Now, just wondering whether it is related to crude oil, but
Oh,
I don't know.
okay. Here means I could give you that the uh, petrochemical. All right, petrochemical industry. It's a big industry. I mean, from the crude oil that I already said in the earlier of our meeting, and months ago maybe. Petrochemical industry could be divided into three steps, into three streams:
Yeah.
upstreams, midstreams, and below streams.
Downstream. Downstream.
Downstreams, yes,
Downstream
downstreams.
is dependent to
Yeah.
upstream. Okay, okay.
Yeah, maybe uh, the place that you can see is midstreams or downstreams, right? Midstreams, like you just extract the ethanol. Ethanol could be
Right.
retrieved from the petrochemical. I means the crude oil, and from the ethanol could be used for many usage, right? Like resin or glue, like malayat anhydride could.
Alright,
Malayat
alright.
anhydride is originated from the crude oil also, and it could be midstreams between the upstream and the downstreams, and the downstream of the malate anhydride is resin that the the usage is very widespread too.
Hmm.
Right.
So yeah, that's why petrochemical industry is really huge until America won't destroy your country.
Uh,
Okay.
okay, okay.
But I do understand. Like, I can see why crude oil or oil industry in general is very highly profitable business because,
I mean,
uh,
Aramco is.
yeah, yeah. I guess it's kind of
In
like,
the middle of technology companies.
like one of just using one of products there, like one of the resource there, the crude oil, it could be transformed into
Various.
various type of products like kerosene, or like naphtha or something like that, yeah, and many other things. That's why it's pretty profitable. That's something
Your
that I
laptop contains plastic too.
Yeah, that's true, yeah, I guess that is why, like,
Yeah.
it is highly profitable, and changing maybe changing our car into transform our car into electric car does not like making our industry
Poor.
go away, basically.
Alright.
Yeah. So we are, and I think our time is up. I guess it's 3:10.
Oh, okay, okay.
Yeah. So let me just summarize a little bit what we learned here. So we learned about two type of separation method in chemical. First is distillation, which basically boiling a mixture, utilizing the difference between the boiling point of two types of element, and then uh, basically separate it when one of the element being turned into gas and condense it, then separate it, which separates both of the mixture. And secondly, the absorption, use which only use in the gas, for the gas, a mixture of gas, and then let's say put it on the column with trinklet of water, not water, just liquid absorption, absorption, and basically the absorption will absorb the gas, the reactive gas, not the inert one, which basically separate the inert gas and the reactive gas, which could be used as well, any other kind of use, actually. Yeah. So what I really kind of fascinated with is in the industry scale. In distillation, well, distillation is pretty much distillation. It's not that hard to grasp, but the absorption part is pretty cool, actually. Like, uh, no, sorry, the distillation part for industry, especially in oil, is pretty amazing because you can see that one column of distillation could be used for creating, for transforming the crude oil to many various type of chemical products. I thought it was kind of different oil transformed in a different product with different method. Like, for example, if you want to do kerosene, you can transform it in this way. If you want to do naphtha, you can transfer it in certain way. But this shows that only using one distillation method, you can produce many type of product. Uh, that's so clever, from what I see. And the absorption part, well, it is pretty good for the environment, from the example that Andres shows today. So yeah, this is very interesting, and I learned something today. How about you, Adil?
Yeah, of
do,
course,
you,
I've learned
do you
something.
learn something today?
All
Well,
right.
this.
I just want to add some insight. I mean, Singapore. Singapore actually is rich because it would
Hmm?
apply the refinery or the distillation of oil. The oil could be got from the Middle East or Brunei. So
Also,
the Brunei is
refining.
rich because of the upstream, and the Singapore is rich because of the midstream industry of petrochemical. Yeah,
Also, the refining ones are, of the resource. All right. That's.
Singapore just refining one from the uh, oil rich countries such as Brunei or Middle East.
Do Indonesia have such company like the midstream?
Yes, we have the biggest refinery in Cilacap, and now Pertamina is building the second biggest of refinery in Balikpapan.
Refinery. Okay. In
Yes,
Balik.
I hope that it will go well.
Good. I see. Okay. I think that's enough for today podcast. Well, anything else want to add, Adil
No,
and Andre?
I think it is enough.
All right.
Yeah,
Okay,
it's already
then
after.
yeah, it's almost Asar right now. So, all right. Shall we close it, everyone? Like,
Yeah.
okay. Thank you, for today podcast. Thank you, Andra. Thank you, Adil, for joining us, and then thank you all, the audience, for joining. If there are any, please subscribe and like, comment to Adil channel to see every updates from us. That's it. Have a good day, everyone. And closing the stream.